guys, Market here. Today we're going to look at simultaneous equations. We just want to get a brief idea of what they are and how to go about finding solution of those. This is just like an introduction to simultaneous equations. We will be covering the elimination and substitution methods in a later video. So look, here I have a picture which shows two lines. These are formed from two linear equations, and where the arrow is pointing is to where those two lines intersect or cross. We can say the solution to this is at that point. So where the lines cross or intersect, that's the solution to a pair of simultaneous equations. We can also say that it is the solution. We can say it's the point of intersection. Here's another one. We can see that the point of intersection or solution to these two linear equations is 5, 3. So when x is 5, y is 3 for both of them. That's where they cross. That's the solution. So one thing that we want to be able to do is to determine whether a point is a solution of a pair of equations. So they give us a point 4, -2, and they're asking us, is it a solution to 2x plus y equals 6 and x minus 3y equals 8? The first thing to do is to label the equations. This one I'll call 1 and this one I'll call 2. I'm going to sub the point into equation 1. So 2 times 4 plus -2 equals 6. 8 minus 2 equals 6. Yes, that is correct. So that is a point which lies on 2x plus y equals 6. Let's see if the point also lies on x minus 3y equals 8. Sub the point into equation 2. 4 minus 3 times -2 equals 6. 4 plus 6 equals 6? No, 4 plus 6 equals 10. So this point does not lie on the line x minus 3y equals 8. To answer the question, we would say 4, -2 is not a solution. So these two lines do not intersect at this point. They do not cross at 4, -2. Keep in mind that a point is a solution if and only if it makes both the equations true. In this one, it made the first equation true, but it didn't make the second equation true. So that is not where the lines intersect. Let's see if 9, 1 is a solution for these two equations. Label them. Sub the point into equation 1. 9 plus 3 times 1 equals 12. 9 plus 3 equals 12. Yes, that point does lie on that line. Let's sub them into equation 2. 5 times 9 minus 2 times 1 equals 43. 45 minus 2 equals 43. That's correct. That point also lies on that line. So therefore, 9, 1 is a solution. This is where those two lines cross one another. Let's now solve a pair of simultaneous equations using a graphical method. So here are equations: y equals -2x plus 6 and 2y plus 3x equals 9. You need graph paper to do this because if you do it freehand, you're not going to get an accurate solution. Let's label the equations 1 and 2. Let's sketch equation 1. So c equals 6, there it is. And from 6, we need to go down -2 and across 1. So that takes us down to 4 and across 1 gives us a point 1, 4. We make a line there. That's our first equation. I've used the y-intercept and gradient method for this one because it is in the form y equals mx plus c. Let's now sketch equation 2. This is not in the form y equals mx plus c. I'm going to use the intercept method. The y-intercept is when x equals 0. So 2y plus 3 times 0 equals 9. 2y equals 9 and y equals 9 over 2. So we have a point at 0 and 9 over 2. There it is. Or 0 and 4.5. Let's now find the x-intercept. So that's when y equals 0. 2 times 0 plus 3x equals 9. 3x equals 9 and x equals 9 on 3, which is 3. Our point is 3, 0. There it is there. I draw my line through and there we go. Both lines go through the point 3, 0. this is a coincidence that our x-intercept is also 3, 0. The point of intersection could be anywhere, but for this one it happens to be at 3, 0. We answered the question by saying 3, 0 is the solution, or 3, 0 is the point of intersection of the two lines. Let's solve some simultaneous equations using cas now. So here are the equations, 3y plus x equals 0 and 2y equals 3x minus 22. I go to main and it takes me to the main screen. I go to 2D and I press that button there and that gives me that thing. What I do with that, I type the equations in. So in the top box I type 3y plus x equals 0. In the bottom box I type 2y equals 3x minus 22. Then, in the third little box, I write x comma y. That's telling the calculator I want to know what x and y are. There it is there, and that's really important. When I click EXE, it tells me x equals 6 and y equals negative 2. There it is there. So my solution is 6, negative 2. The point of intersection is 6, negative 2. Some simultaneous equations have no solution. Let's talk about why this might be. So here is my calculator again. I've written my equations in. I've put x comma y. And then when I press EXE, it tells me no solution. That's weird. Let's see why. I'm going to check the gradients. So y equals 2x minus 4. The gradient is 2. That's easy. For 3y minus 6x equals 10, I'm going to need to rearrange it. When I rearrange it, I get y equals 2x plus 10 on 3. Look at that, my gradients are the same. That means my slope is the same, and that means my lines will look something like this. They're parallel. Parallel lines will never cross. So if two lines have the same gradient, you're not going to get a solution. And therefore, we can say that there is no solution to y equals 2x minus 4 and 3y minus 6x equals 10. And that's the end.